Okay, hello, welcome to today's talk of the Offensive Security course. It's a final talk and event of this term, and again we have an international speaker invited, and as usual I like to make a quick announcement before we start. My name is Carsten Fellmann, I work for GData, and we are sponsoring this course to make it possible to invite international speakers, and we are very happy that it's working quite well. And in addition to this course, we offer a small evening event today for the last time this term, and this basically means we are going to our company and offer some food and drinks, and hopefully have some nice discussion about today's talk or things in general. So if you're interested in joining us today, you all are very welcome. And yeah, if you'd like to take the opportunity to ask some questions in detail about the talk, or just to talk to some of the guys working in the antivirus company, yeah, that's a great chance, and I think you should all take this chance. So I guess you want to say something about the evaluation today?
That's true. Yes, thank you, sir.
Yeah.
We have some evaluation sheets over here. I would be very glad if you could fill them afterwards and just let the camera people and everybody know how you like the event. It is very important for us. And now I would like to welcome and introduce my good friend from France, Nicolas Gregoire, and he's gonna talk about attacking XML processing. I've already seen the talk on Hack in Paris, and it's pretty awesome, so enjoy.
Hi all. So effectively I will talk about XML processing and the security aspect of this kind of processing. First, a very quick introduction about myself. I have been working in information security for more than 10 years, 12 years, and I own my own company since 2 years. And 18 months ago, I had a customer who asked me to audit several XML digital signatures applications. So I know there is a lot of XML digital signatures guru in Bochum. In fact, I compromised 3 targets, which were 2 server-side and 1 client-side, and it was really fun to pop some shells on some very critical servers. So I chose to investigate more, and now, so 1.5 years later, I have a big bunch of vulnerabilities related to XML at large. In a lot of products, so you can see some icons. There is a server-side component like LifeRay or PHP or .NET Nuke. You have some browsers, Firefox, WebKit, database, Oracle, Postgres. No, but I have some bugs, but I forgot to put it. Adobe, etc., etc. And so I will speak about XML at large. So I will begin with a quick introduction to XML in order to speak with the same terms and in order to be sure to understand the following parts. Then I will speak about encapsulation, which is the fact of hiding interesting data inside the XML document. We will use encapsulation to evade some antivirus solution. Then look to temporary or limited denial of service attacks in order to detect some kind of processing in black box mode. We will try to freeze the server during a few seconds. And then some very technical parts about exploitation of XML external entities vulnerabilities and XSLT vulnerabilities. Okay, so XML stands for Extensible Markup Language. We will define these 3 terms with relevant inputs to security. So markup. So it's like HTML. Everybody understands this kind of stuff. It's angle brackets everywhere, and you can have some attributes, some children here. Everything is like in HTML. The second term is extensibility, which is very, very important in XML in general and when looking for vulnerabilities. In fact, XML use namespaces, and namespaces will define the precise meaning of a tag. And most of the time, a namespace is defined by a URL. So I have a very quick example. You have a pseudo HTML document with two namespaces. So this namespace is XHTML1, which is a default namespace. And here you have a full namespace with a private URL. And when parsed by your browser, the browser will not understand the U tag in the full namespace, so no specific processing, but it will understand the U tag in the XHTML namespace, and so the word will be underlined. So it's just a very basic example in order to show how a browser, how namespaces will impact browser processing. In fact, it's mainly used in order to avoid ambiguities. For example, if you have a document with a font tag, it could be relative to SVG, for example, or XHTML, or a very obscure Oracle configuration file. So that's a namespace which will define the meaning. And it's very important for triggering specific features. So these three namespaces are related to well-known vulnerabilities. The first one allows to trigger PHP code from a XSLT style sheet. The second one allows to create a local file during XSLT processing. And the third one allows to execute Java code during XSLT processing. So if we don't know which namespace we can use, we will miss some very important features and vulnerabilities. So when I study XML or XSLT parsers, the first question is which namespaces are available and which features do they provide. The third term is language. And in fact, language means that there is much more than only data. Everybody knows that XML can be used to store data. It's a main use. But you can also have code, like XSLT, in a valid XML file. You can have a DTD, document type definition, which is the grammar of the document. And you can even find some processing instruction which will instruct the parser to trigger some specific processing on the source document. That's an example of a somewhat complex XML file. On the first line, you have a processing instruction. Here you have a doc type, which is the grammar, then some XML data, then some XSLT code. And the overall goal of this document is to dynamically generate some SVG file. The question is it really important to have this kind of XML file? Of course, because the code I have shown is several interesting things. First is XML document with embedded XSLT code, so you don't need to have an external document in order to store your code. It's a dynamic SVG image, so depending on the rendering software, you can have different generated output. And it's a proof of concept for WebKit vulnerability, which allows to drop file on the victim hard drive. So if we open this SVG in several browsers, we get this kind of output. So transformix, which is the internal name of the XSLT parser of Firefox, you get a green circle, which is not vulnerable. Same thing in Opera, but if you are using Safari or any WebKit-based browser, but Chrome, because of the sandbox, you will get a red circle, and the proof of concept code will try to drop a file in the TMP directory. So if you open the SVG file in your browser, for example, in your iPad, need to check in TMP if there is a file which have been created. There is a very large quantity of use cases for XML. So I have a few examples. I have already covered SVG and XSLT. Web services use XML a lot, REST, SOAP, or XML RPC. For example, when you are reading blogs, you are probably using RSS or Atomfetch, which are XML2. Under VLC, your playlist can be in XSPF format, which is XML2, etc., etc., etc. So there is a lot of place when we can play with XML documents in order to trigger some vulnerabilities. I have some screenshots of a real-life website. This is Microsoft Link, which is a Microsoft solution for audio conferencing. And the application asks the user to select the XML file that the provider gave you. So we can suppose that the document will be parsed server-side. That's an application published by the W3C. So it's an XSLT gateway. You can provide your XSLT code and your XML data, and the processing is done server-side. It seems that there is a remote code execution vulnerability in this gateway, but I didn't check in details. I don't know if Chronopost is known in Germany. In French, it's a shipping service. And if you are using the professional version of the service, you have access to a web interface, which allows to track your shipping. And in fact, this is the name of the servlet, and the parameters are XML URL and XSL URL. And the fun part is that it's exactly the same names that the sample application shipped with Xalan J. So the same servlet name and the same parameter name. So it seems that this professional service is using the sample application of Xalan J in production. And this sample application is very, very easy to compromise. So I didn't check this specific one, but it seems dangerous. And that's Google Doc, which is in URL, XSL URL equal HTTP. And you will find a bunch of websites. And the interesting part is here you have ASPX. Here you have some XQuery. Here some Java, and here some PHP. So everybody is using XML and XSLT, and it's independent of the underlying platform, processing language, etc., etc. A small point about the auditing of XML-enabled application. There's a few questions we need to answer. The first question is what vectors are available in order to inject or to feed XML content to the application, which is a very classic question during auditing. If we found some vectors, we need to wonder, is this XML content processed, which could be self-evident, but not in every case. For example, if you upload the SVG, which is XML, file to Wikimedia, there is an automatic conversion to PNG because some browsers do not support SVG image. So it could be easy to miss this point. You upload a SVG file, and there is automatic server-side processing on your uploaded file. Then, if you find some processing, you need to identify who is doing the processing and where. Where means client-side, server-side, or in some very complex B2B environment, you can find some gateways which are used to transparently modify XML documents, for example, in order to support several versions of the same specification. And it's easy to miss this kind of processing points. And if we take the example of blog feeds, you can have some client-side processing in your browser or in a dedicated software, or you could have some server-side processing. For example, if in your Google homepage you can display some Atom feeds, which is doing some XML processing server-side. And then, once the processing points are identified, we need to wonder what the attack surface of this specific processing point is. And so we have a very large list of questions. And the main one are, can we process arbitrary data? If yes, can we feed processing instruction? Are they executed? If we can feed some DTD, will external entities be resolved by the parser, which open a large family of vulnerability, which is XML external entities attacks? And if we can process XSLT code, which extensions are available? I have a few demonstrations which are based on some Atom readers. So this is a very basic description of Atom feed. You have a root tag, which is feed, then the title of the blog, and then for each entry you have several children, including title, date, author, and several things. And that's the infrastructure for the demonstration. So I have 4 server-side application processing XSLT Atom feeds, one using Perl and a library dedicated to XML, to Atom feeds, and 3 using XSLT, 1 under PHP 5, 1 under Postgres, and 1 under Tomcat. And I have a client-side processing under Firefox, given that Firefox can process Atom feeds. And we have the internet, which is simulated, where some Atom feeds are available. And of course, we have an attacker. Alors, I will show you. OK, it looks like that. So we have the different applications here: Perl, PHP, GSP, Postgres, and Firefox. Here we have the Atom feed we want to parse, and here we have the XSLT code used for the layout. So in Perl, it's very simple. We have a dedicated library, and we can get the entries and iterate and print them. And PHP, PHP is very basic. We get the 2 documents, the XML and the XSLT, and then we execute an import style sheet and transform to XML, and then the feed is processed and displayed to the user. And it's exactly the same thing for the JSP. We get the 2 parameters, and then we execute the transform here. Oh, excuse me. And Postgres, it's here. We are using XSLT process in order to do some processing by the database. Nobody will use Postgres in real life to do XSLT parsing of Atom feeds, but given I have a bunch of vulnerability in Postgres, it could be used as a nice demonstration. OK, what else? OK. OK. So I have 2 local copies of some Atom feeds, the URCert and the Adobe one, and 3 different layouts. So if I take the first layout with Adobe, I send to the PHP application. I get a very basic output with the entry number, the entry size, and the title of the entry. And if I use another XSLT style sheet, I will get another layout. OK, I have a fixed port, and then some links and the date and everything. And I have a third layout, which includes the content of the entry. So it just to show that XSLT is very useful to do the layout, and so we can find a lot of business use case. Business use. For example, you have an application which can be accessed by a browser or by a mobile, and you are just feeding a different XSLT style sheet for in the two cases, and you have the same data server side and just a different layout. And of course, if I open in Firefox, Firefox will detect that it's Atom feed, will parse it and propose this page where I can subscribe to register the feed, Google or Yahoo or anything else. Okay. So the Perl one is not using XSLT, so we have a static layout. But all the other applications, PHP, JSP, and Postgres, we can modify the layout with this parameter. Okay. So we will first speak about encapsulation. This is a screenshot of the Wikipedia page of the XDP file format. We can see that it was created by Adobe a long time ago. And the very interesting fact is here. In fact, XDP is a container for PDF and XFA, which is interesting, but it also can be contained in PDF. So it's evident that we can play something like Russian dolls and put PDF inside XDP, inside PDF, inside XDP. And the goal is to know how much layer we need in order to evade the antivirus detection of a malicious PDF file. So the setup is very simple. I generate a malicious PDF file with Metasploit using the cool type vulnerability, which is something like 2 or 3 years old. So that's the default Metasploit option. And here I get 8 out of 9 antivirus detecting something strange, and here 27 out of 33. Which is not a very good result for a 3 years old vulnerability, but it's something, there is some detection. And that's the patch for Metasploit in order to add XDP generation to any PDF exploit. So in fact, you will call make XDP with your PDF in parameter. You encode your PDF to base64, you put the value here, and this is your result XML document. Okay? There is 2 interesting points. One, antivirus detection, and 2, an easy way to exercise the XML and XSLT parser in Adobe. Because when Adobe will open this document, of course, it will process like XML, and so you will trigger the XML parser in Adobe Reader. So the results are good. We get 0 out of 9 and 0 out of 43. So it's perfect. The only problem is that Adobe will extract the content in base64, decode it, and write it to disk. So if you have a local antivirus solution, it may detect the PDF when it's written on disk. But for gateways, like for emails, for example, it's very easy, and you are sure to go through undetected. Sophos claims that they can detect a malicious XDP file following an alert from the US CERT, the UK CERT. I asked them if they are really XML aware. Are they okay with namespaces and things like that? They didn't answer. So if somebody have a recent version of Sophos to play with, it could be a nice activity. So we have seen that with 10 lines of XML, we can evade any antivirus, gateway antivirus, which is an easy win. And there is a lot more, lot of additional content in encapsulation. For example, if you have some exploit for VLC, the media player, you can put your exploit in a XSPF playlist and trigger the, for example, the overflow when the playlist is sparse, and it works very well, but I have no demonstration. Okay, next, limited denial of service attacks. So the goal is to get resource starvation in order to detect from the outside the behavior of the application. The first processing we want to detect is DTD processing in Wikimedia. As I previously said, when you upload the SVG file to Wikimedia, you have a conversion to PNG. If the DTD is processed, you may have some XML external entities vulnerabilities. So we need to detect in black box mode if the DTD is processed. So we'll use something very well known, which is the billion love attacks. And it's very simple. You define a variable which is, its name is lol, its value is lol, and then lol1, its value is 10 times lol, lol2 10 times the value of lol1, etc., etc., etc. And then in your document, you will reference lol9. So you can imagine what will happen. If we do some quick math, lol is 3 characters long, which is 3 bytes, and we get 1 billion lol, and this is 3 gigabytes, which could be enough to slow down the server and allow us to detect that the DTD is processed server-side. Now we want to detect if an application supports XSLT, for example, XML digital signatures application, which are funny because the specification says that you can support XSLT, and the best practice say you should not. So the question is this specific application supporting XSLT? And we have something very similar. You have a function which is XSL number, which is used to convert one format of number to another format. And here the I format means Roman numerals. So here we are asking the XSLT engine to convert 1337 to Roman numerals, which give this kind of output, okay? Everybody understand this, I think. The important point is that M in Roman numerals is the biggest unit. So, for example, if you have 1 billion, you can express 1 billion in Roman numerals, which means that we have an easy attack. We will ask to convert a very large number in Roman numerals, and then you will get M, a lot of M, which is 1 gigabyte in memory. So it's exactly the same principle. We have a way to trigger a very long string, providing very short one, and so we will try to consume a lot of memory in order to detect the processing. Okay, so that's exactly what I have shown you, but I'm using lol6 and not lol9 in order not to crash my computer during the demonstration. So if I feed that to the Perl application, it works. I have a 4 megabyte output string. If I give to PHP, I get detected an entity reference loop error message. which is somewhat a good idea from PHP. In fact, it's a libxslt code which include protection against this kind of attack. GSP, it works by default, and Postgres, I get the same output than PHP because they are using the same underlying component, which is libxslt. And if we feed it to Firefox, it's slow, so it probably works. Okay. So it works. I don't know if you see the scroll bar here. It's very small. Okay. So that's the Beyond Love attack. The XSL number 1, we will use a small value, just not to crash my computer. Always the same problem. If we give it to PHP, it works. GSP, you get an error because you can't convert to Roman numerals a value which is greater than 4,000. I don't know why. It's probably a protection against this kind of denial of service attacks, but it's not documented anywhere, so I don't know why. Postgres works too, and Firefox is not using SSLT, so this is not relevant. Okay, so now the main technical part. XML external entities attacks are probably the most common XML-related vulnerability. You can find it everywhere, and it's very basic. You define a DTD with an entity. Its name is ref. Its value is the content of the etc password file. So that's very interesting. You link to a file, and you get the content of the file in your variable, and then in your document you refer to this variable, and you get the content of the etc password file. So it's quite basic. That's a partial list of vulnerabilities, XML external entities vulnerabilities published since last year. In bold, it's vulnerabilities I found myself, and in red, it's vulnerabilities in libraries, so which may affect much more than one software. So you have some interesting things. For example, this is used for speech synthesis software. For example, when you are calling your bank, asking for how much is on your account, it's probably this kind of software. This is some REST library here and here. SharePoint, for example, a lot of things. The impact of XXA attacks is often underestimated. The most basic impact is the reading of ASCII or UTF-8 file, but you can also blindly hit the internal network. For example, in order to to access a specific URL on a specific server on the backend, typically Tomcat administration page, or you can do some banner grabbing, looking for a web server on port 22 and fetching the SSH banner. Depending on the underlying operating system, you can steal some NTLM hashes under Windows, because you can request some remote file via SMB, and so triggering NTLM authentication. And under Java, you can list the content of directories, which is very, very useful when you are looking for a specific configuration file on a machine, on a box you don't know the directory layout. And in some very specific case, you can read binary file, mainly under PHP. You can ask some internal LDAP servers for any request and get the info back. You can execute arbitrary command in PHP and much more depending on the underlying parser and a lot of specific options. So it depends mainly on the XML parser itself, the operating system. As I said, under Windows, you have all the NTLM hashes stuff. The programming language, because every XML parser in Java will share a common set of features. And, of course, the application-specific features, which are dependent of the application itself. So under using the file URL handler, you can, under Java, steal hashes. Under Unix, you can access a pseudo file system like proc, for example, and under Java, directory listing. Okay. PHP is very interesting because it has a lot of URL handler. So HTTP is useful because you can get the banners. So this is a SSH banner. This is a VNC banner. You only need to have a PHP error message displayed to the user. The PHP URL handler is magic. In fact, you can, using this syntax, in fact, you will tell the PHP engine to read this file and to apply base64 encoding before giving the content to the application. It means that when you will do a read on the file handle, you will get base64 encoding data. And it's totally transparent for you. So it's very useful. We'll see in the demonstration. And this is an optional module. You have the SSH2 URL handler, which can be used to access a remote file via SSH. So all you need is a URL, for example, the local one, and a weak password for any account. So I choose Oracle, and then you can read the Oracle configuration file. But this is not the default configuration. If you are not in default configuration, you may find the aspect URL handler. It's trivial. You just need to put your command like ls or cat etc password after the URL handler, and it will be executed by PHP. Okay. So that's very basic. We will refer to file etc password, and here we will call we'll get the value. So in Perl it works, no problem. PHP it works too. GSP and Postgres are under Windows, so it's not relevant. But the interesting part is that if we use proc self map instead of etc password, we will get some information relative to the current process, which is the meaning of /proc. So if I execute it under PHP, I can see that I'm in Apache 2 process. And if I have a vulnerability in Apache, it could be useful to find the heap and the stack address, for example, bypassing ASLR. And if I execute the same code in Perl, as you can see here, we are in a Perl application, and we can list any module loaded, like libz, for example, and still get the address of the stack and the heap. Okay. Under Windows, we will try to read boot.ini. Okay, I have a bug. Okay. So it works fine with GSP, and the problem with Postgres is that the file syntax is different. So this specific code only works with GSP, but it can work with Postgres too. So here I only try to read pg_hba.conf, which is a Postgres specific configuration file, and so I ask the Postgres process, and it's very easy. I get the configuration file, and here I can see which network are authorized to access the database. Okay. So, for example, if I'm requesting pg_hot, which is the password file, I can get back the MD5 hashes of the password. So I just need to crack them later in order to get the password of every configured Postgres account. Okay. Very classic. I will ask via NetBIOS a remote file on a share which is called evil share. And here I have Metasploit. And I will just use the SMB module for capturing credentials, and then launch it here. And then I request using Postgres the parsing of this file. Okay, we have a problem. But here, as you can see, we get the LM and NT hashes for user Enterprise DB, which is a Windows user under which is running Postgres, which is the professional version of Postgres, not the open source one. If you are using the open source one, the user is named Postgres, and here it's Enterprise DB. This account is not local admin of the machine, which is a pity for us, but we can still either block the hash using a rainbow table, for example, or replace the hash if we have another machine using the same account. Okay. Here the PHP filter. So we will read etc LSB release using ROT 13 and proc self CMD line using base 64. What's the goal of this demonstration? First, if you have IDS which is looking for root colon, for example, like etc password going outside, you just need to encode in ROT 13, and then your IDS is blind. And here, excuse me. Okay, and proc self CMD line is a file with null byte inside, so you can read it using classical XML external entities attacks. But here, given that you have a base 64 encoding before reading the file, it works fine. So we send this to PHP, and here we get our ROT 13 encoded file. Which is the LSB release file, no problem. And here we get some base 64. And we get Apache 2 -k start. And in fact, between Apache 2 and -k, and between -k and start, you have a null byte. This is why you can't read this file using classical XML entities, and where the PHP filter is really useful. Okay. Then I will connect to localhost 22 and get the banner here. So it's Ubuntu, so it's very, very, very verbose. You know exactly which distribution I use, with which patch level. Okay, and SSH, where I will connect using the root account and a very weak password, and try to read the etc shadow file. And of course, it works. It's a little slow because we need an additional SSH connection. But as you can see, I have two real accounts, Nico and root. So of course, you can brute force the password and do a lot of tries, and in order to detect the password on the backend. Okay, here's the last one. It's a simple directory listing under Java, and it works. Okay. No XSLT. So I don't know if some people have seen my conference, the conference I gave last year about XSLT. It was exploitation, abuse of XSLT features. So I chose to investigate more, and I have a lot of more content. So a quick introduction about XSLT. It's a functional programming language defined by the W3C last century. Functional is very important because for the exploitation, we'll see it's a real problem. And its main use is to transform XML content in another thing, which could be XML, for example, extraction of data, which could be PDF, SVG, whatever you want. So most of the time, when you have some post-processing of XML data, it's done in XSLT. It's Turing complete, so you can do a lot of fun things. And okay, the menus are displaying to human or data extraction and converting between formats. For example, OpenOffice and perhaps Microsoft Office, I'm not sure, is using XSLT each time you ask to convert OpenOffice format to a Microsoft one, for example. The content is XML data, and you just need some XSLT processing. Where can you find the XSLT engine? So word processor, like I said, a browser, of course, web application, and databases. Nearly every database have a XSLT engine now. It's very fashionable, and it's very dangerous. And that's a partial list of XSLT engine I played with. So it's easy. In green, it's engine without any features. No, it's engine safe, but they usually don't have a lot of features. In blue, it's XSLT engines which are safe by default, but you can easily modify the default setup and get something like a remote code execution. And it's in red, it's engines with vulnerabilities, which could be by design or implementation vulnerabilities. There is both. Okay, that's the introduction. Fuzzing. I have played with mutation-based fuzzing of XML and XSLT engines. It was very stupid fuzzing. I have a few XSLT engines in my test bed. I have something like 6,000 input file, XSLT input files. I have a diversifier, and I do some monitoring, and then I eventually get something interesting. The diversifier used is Radamsa, which is very, very, very good for his job. So if you are doing mutation-based fuzzing, you should know about Radamsa. And the monitoring is done using Valgrind. It's under Unix only. If I don't have the source code, I will use Valgrind, for example, for the Oracle XSLT engine. And if I have the source code, I will recompile it using the address sanitizer, which is a plugin for LLVM, which allows to detect a lot of vulnerabilities like use after free or heap corruption and a lot of well behaviors. So, a fuzzing campaign, the only result interesting is how much bug. So I have plenty of them. I have a few bugs are already public, so I will speak about this one. This is the first published. It's a Mozilla one, and the interesting thing is that if you take a specific SVG file, you only need to replace the SVG namespace by the XSLT1, and you will trigger a very complicated code path in Firefox, leading to a crash. And when I reported the bug to Firefox, nobody was able to understand the precise behavior, and so they choose to play safe and say it's probably vulnerable. Exploitable. This is in Oracle, so that's the Oracle error code for segmentation fault. As you can see, the frame pointer is attacker controlled, so we have a basic buffer overflow with full control for the attacker. And this is how to access the XML engine in Oracle, so you just need to fuzz here. And it's very similar for other databases. This is Adobe Reader. So this bug is specific to Linux under Reader 9, so it's not very interesting. I don't mind publishing it. I have some bugs on Adobe Reader 10 under Windows, so this one are not. There is no patch available for the moment, so I will wait a little bit. And there is much more. I have a few demos, I think. Okay. This is the smallest Firefox crash I have. As you can see, a right parenthesis is missing here, and that's enough. Look. Oops. Okay, and Firefox is not working on this bug, so I don't mind publishing it. And this one is really easy. I just need a specific DTD. You see, we have 4 stars here. Okay, and if I call, for example, PHP. Oops. Oops. Okay, so I keep crashing the PHP process, but it's not very visual. I have something more visual. Okay, this is Postgres, the professional version, Postgres Advanced Server under Windows. So you have a bunch of process waiting for users. Okay, and then I ask Postgres, and look, oh, it should crash. Blah, 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 blah. Ah, okay. So it's in French, but it's a classic, the software have crashed. And then Dr. Watson will crash too. And then everything die. Okay, look, everything die. And this one will die too soon. Usually. Okay. And there is no more Postgres process running. And if I go back to the application, of course, I have no more Postgres server enabled to connect to Postgres. So you can totally crash the professional version of Postgres using 2 lines DTD. And I need to restart Postgres. And it's back. Okay, perfect. I reported this bug to Postgres. They don't see any emergency in acting, so I don't care. So it was fuzzing Firefox libxSLT. Okay, done. Okay. So now specifically exploitation. So you find XSLT code execution somewhere, and you want to exploit for something very specific, like gaining a shell or brute forcing on the backend or everything. And but in fact, if you look at the Wikipedia definition of functional language, you will find that theoretical goal is to avoid state and mutable data, which means in real life that you have no for loop, no while loop, and every variable is read-only, which is pretty complicated in order to program something. But we need, as a pen tester, we need to brute force, for example, a password on the backend for SSH, or we need to read std out if we can execute a command. So we need a while and a for loop. The question is, how can we emulate this kind of behavior using XSLT? So brute force is quite easy. You will put the data you want to iterate in XML format, and then you will use the XSL for each construct. So that's a typical example. You will use, we want to use WebKit file dropping vulnerability, and we want an exploit which is generic, which works on every platform. So we have 5 different locations for the output file and 1 content in blue. And then we have a small for loop, which will try to create a file for these 5 locations. So the code is here. We, for each location, then try to create a file. It's very basic, and it works. The interesting thing is that some XSLT engine provides some SQL extensions, so you can access a SQL database from XSLT. So SQL extension and for loop mean you can have a XSLT style sheet which will brute force the credentials on the internal database, which are unreachable from the outside, of course, and so which may have some default account. Okay, the for loop is okay. Now the while one. It's much more complicated, and we will need to use some XSL template, recursivity, and a code generator because it's really complicated. So there is a German guy who released something like 10 years ago, XSLT loop compiler, which will add 3 new keywords, which are loop update for variables and loop for and loop while. And then the code generator will translate this construct to valid XSLT code. Just in order to show the complexity, that's a 4 line of Java. it's very basic. We will read the output and put the content in a global variable, which is result. And at the end of the loop, we just print the content of the result variable. So it's 4 lines in Java. If we use the XSLT extensions like loop last and loop update, we get 18 lines. We can find the read line here and the print here, and here the concatenation of the current line with the result variable. And after conversion to valid XSLT code using the loop compiler, you get something like 50 lines of code. And this is really too much complicated to write manually, so we use the code generator. But it's valid XSLT code, so you can have something. While loop in XSLT, it's not short, it's not easy, but it works. No. See? Yes. So here we want to do a for loop. We have a large file with a list of Java properties. Okay, like Java Home, for example. And we have a style sheet which will do for each property print its name and print its value. So it's effectively a while loop, for loop, and it works fine. And we can get a lot of information related to the underlying JVM. So that's a for loop, and this is the while one. We define 3 commands that we want to execute on the backend. And here we have our complex XSLT code with the while loop, okay? And if we execute that on the Java backend, we get the name of the command and the output, the name of the command, the output in French, sorry, and the name of the output, the name of the command and the output. So of course we need a while, because with a for loop we don't know if we need to read 2, 10 or 20 lines. Okay, so now we get for loop and while loop, but there is much more. Suppose you find a way to provide arbitrary XSLT code to an application, and that this XSLT application have a way to execute high-level code directly from the engine. It's mainly PHP, .NET, or Java code in what I have found in real life. And this setup is not so uncommon. I mean, by default, PHP do not allow that, but if you call register PHP function, every PHP function is reachable from XSLT, which is very useful. In Xalan-J, which is a XSLT and XML engine for Java, by default you can execute Java code. And XML Spy is a client-side application used to generate or analyze XML document, and you can execute Java or .NET code from XSLT style sheet. Oh, in PHP it's trivial. So you have this namespace, okay, PHP.NET XSL. You map it to the foo keyword, and then you can call foo function, and then the name of the function and the arguments. But okay, first I have a demo here. So if we want to call PHP info, you need here the namespace, which is mapped to PHP, and here PHP function PHP info. It's very basic. it works. But if we want to execute arbitrary PHP code, not only PHP info, we need to, for example, execute require, include, or eval. But they do not work because they are not PHP functions, they are PHP constructs. I don't know the exact meaning, but it does not work in this case. But luckily, assert and preg replace, which are well known for allowing arbitrary PHP code execution, are functions and can be called in this context. So we have everything we need for executing malicious code. So I load a specific module which is generic SLT payload. Okay, I will finish the slide and I will do all the demonstration at once. Okay, so PHP is okay. We can execute PHP like PHP info, and we can execute preg replace for executing arbitrary PHP code. Okay, that's solved. Now Java. In fact, last year, Berlin side, I said publicly that it seems possible to get pure Java and XSLT interactive shell because I found no way to execute my own classes or to execute a thread, which is a dead end. And 2 weeks later, there is a guy which is Michael Chill, Mihi42 on Twitter, who write me and say that I was wrong and it was easy to load and execute arbitrary Java classes in XSLT. So I tested and it was working well. And in fact, this guy has released a tool which is Java payload and which allow to output some typical payload like reverse shell or executing commands in a lot of different Java related formats like applet, bin shell, xlng, etc., etc. So what interests me is the xlng output. And in order to get easy code execution in PHP and Java, I code dedicated Metasploit module, which is still not in the trunk, but you have the ticket number 6784, so you can download the code. And you can gain some Metasploiter shell. Okay. So for PHP, here we call PHP function preg replace the E modifier, which is the interesting bit, and then the PHP code we want to execute, and eval point here to eval base64 decode of this value, which is dynamically generated by Metasploit and which is a PHP Metasploiter. So send to PHP. As you can see, we get a session here. Okay, PHP Metasploiter, fine. And if we want Java, so this code is very complex because it's using reflection in order to get the interesting, to reach the interesting features of the JVM, just in order to fetch this URL and execute the downloaded jar file. So everything is done automatically by Metasploit, no need to wonder. And if I send to JSP, okay, I get another Metasploiter session. Okay, so as you can see, we have a PHP interpreter under www data, which is Apache, under Linux, and here a Java interpreter under system, because Tomcat is running under system under Windows, which is cool. So it works fine, and we get cross-platform for the Java one and the PHP interpreter shell using XSLT. Okay. Final demonstration. Okay. Oh. So here you have a specific namespace which is related to libxslt sax, and here I will call sax output in order to create a local file. This is a vulnerability used in WebKit last year and XMLSec and PHP 5. And I found last week that it works on Postgres too. So it's exactly the same code that last year, okay? No modification. This is the body of XSLT. And okay. Okay, here you have only a Postgres specific file, okay? But if I try to execute this XSLT file, I should have a owned.txt file created on the server. Let's try. Okay, no error. Up. And here you get your owned.txt file, which is created server-side. In this case, it's not very useful, but we can use the file reading trick in order to get the authentication file, add our own account, and then overwrite the existing file with our own version. In fact, backdooring the server by adding an administrative account. Okay, that's all the technical content I have for the moment. Conclusion about this whole story. XML is everywhere. Everywhere I look, I found some XML content which could be interesting to attack. I found yesterday another vulnerability where SVG files are rasterized server side, and then I can use this process to steal file on the server side, and it seems to work on Wikimedia, on some instance of Wikimedia, so it could be interesting. The main thing you need to remember is that XML is not data. XML is a document which could embed data, grammar, code, etc., etc. There is no vulnerability if you have only data, but if you have DTD, you have XML external entities attacks, and if you have code, you have XSLT code execution, which could lead to interpreter shell in some specific configuration. The attackers have more and more tools available, like generating for loop easily, brute forcer for SSH and things like that. So you need to patch if you have this kind of vulnerabilities. And the very sad fact is that this kind of attacks are not new. The first public references on Bugtrack are from 10 years ago by Guninski, for example, and it seems that just nobody cares, and more XML interfaces are published. For example, REST interfaces are added to a lot of web applications, and that's a possible vulnerable path. So we need to be careful. If you have some question, it's the moment, or tonight if you are joining us later. I have a wiki which is online and on which I have most of my proof of concept code. This wiki is vulnerable to XXC attack, which allow you to steal all the files of the server. It's a cloud service, so I can't patch. So please don't hack my server. And if you have some question or anything else later, you can reach me on Twitter or by email. Thank you.